Hello and welcome to Sudoku. This is an X-sum Sudoku puzzle set by MadMahogany, whose full name is written down here. And it was in a Sudoku Mahabharat, a round that was dedicated to math variants. I love math variants. And this variant is that whenever you have a number on the outside, this number is the sum of the first few digits, and how many digits are in the sum is written here. So, for example, this 10 could be 2 and 8. The sum of the first two digits would be 10. And this 10 could also be 2 and 8, or it could be 3, 2, and 5. That would be the sum of the first three digits, amounting to 10. So how do you solve an X-sum puzzle? Well, the first place of interest is small numbers, because we will have a small number here. It won't be 1, because 1 would be the sum of one digit, and it would make 1. It won't be 3 or more, because 3 digits have a minimum sum of 6, 3 plus 2 plus 1. So it can only be a 2, together with a 3. Same here. And we can already think that 2 and 3 will have to appear somewhere in these 3 cells. 7. 7 can be 2 and 5, and actually can't be anything else. With 3 digits, we can't have the remaining 2 digits have a sum of 4. They would need to be 1 and 3 would repeat. So that's 2 and 5. 10 has more decompositions. It can be 2 and 8. I already mentioned 3, 2, 5. It could also be 3, 1, and 6. And it could also be 4 with 1, 2, and 3. But something of interest is that 2 of those decompositions must appear on this column. So we need to find among those decompositions 2 that have no digits in common. And you can see that all those 3 have digit 2. So this one must appear. And all those 3 have 3 in common. So those ones can't be the second decomposition. It has to be this one. So we have those decompositions for 10, and this one can't appear here. It must appear on the bottom side. And now we have 3, 6, and 1 in this order because of this one. Now, a few minutes ago I talked about those 2, 3 pairs, and with those digits we can now be sure that their good place, that their right place is here. So we took care of small numbers. Let's take care of big numbers, because we know that the sum of all digits on a column or a row is 45. So we know that outside of this sum we must have a total of 5, but we already have a total of 5. So this 40 sum uses all remaining cells, and we can place a 7 here, and this 40 will be fulfilled. This 42 needs to have a sum of 3 outside, but 3 here is not available, so 3 will have to be made with 1 and 2. So 42 uses 7 digits, and now it's fulfilled. Is there something interesting with just classic Sudoku? I don't think there is for the moment. Let's have a look at this row, because something interesting happens here, which is that those sums have a combined total superior to 45. and that's 52, which is 45 plus an additional 7, meaning that the regions that are spanned by this sum and this sum must overlap with an overlapping sum of 7. Well, 17 will be a smaller part, 35 will be a bigger part. 17 uses at least 2 digits, but we see because of the available digits that it must have at least 4 digits. So it could be those 4 digits with an overlap of 7, which will be 2 plus 5. Or if I try to make it 5 digits, then we need to have a sum of 7 using 2 and 3. But then we must have an additional 2 to push this overlap to 7. And it wouldn't work. It would repeat a 2. So the only option is to have a 4 here, an overlap here of 5 and 2, and a 6 here to complete to 17. And because of this overlap, this 35 is the sum of 7 digits. And you can see that with the remaining digits, which are 9, 1, and 8, and we can place them actually, this will work. 15, 25, 35, it works. Nice. Now, is there something? Yes, this one now is here. We get an 8, 9 pair. We still need 3, 4, and 6 in those cells, but well, we don't know how they are arranged. This 22 should be something we can find. Well, the missing digits here are 4, 5, 6, and 9. Well, 9 will obviously not go here. It won't work. If I try to make this a 6, it means that those 6 digits add up to 22, but if you're familiar with Killer Sudoku, you know that 22 with 6 digits does not include a 6. There's only one decomposition. And the other way of seeing that is that if those 6 digits add up to 22, then the remaining 3 digits must have a sum of 23, which they obviously don't. And we can even push this further. So the missing digits on the other side must have a sum of 23, but we already have 2 and 3. So the other digits outside this sum must add up to 18. So we must have at least 3 digits to make a sum of 18. So that's a maximum of 4 digits here, and we see that this has to be a 4. So how do we complete this? We still need 5, 6, and 9 here. Let's have a look. These 3 digits now must be 4, 5, and 7. So this is 5 or 7, 4, 5, 4, 5 or 7. And now how do we make this have a sum of 22? And something tells me that 9 is too much. If I use this 9, I get 13, and this will be too much. This will be more than 9. And same if I put a 9 here. So 9 is not an option here. It has to be an option. It has to be the digit here, making this an 8 and this a 9. And now this 5, 6 pair makes this a 7. And let us check. That's 11, 15, 22. This is correct. And we get a 1, 8 pair here. Those now must be 4, 5, and 6. And it's time to have a look at those sums. Though those clues would not have been easy to use in the earlier stages of the solve because they are medium numbers. Those more extreme numbers, smaller numbers, bigger numbers, are much more useful to begin with. So let's have a look at 18. 18 could be with three numbers, 3, 6, and 9, 3, 7, and 8. It could work with 4 digits, could work with 5. So those are 3, 4, 5, and actually in this column, this can only be a 4. So this is a 6, and that's a 5. So this is a 4, this is a 5. And now we know that this has to be a 3 because of those digits now. So we need 15 here without using 8. It has to be 6 and 9. And because of this 9, this is 6, 9, and then 1 and 7. Using this 7, and it resolves the 1, 8 pair. We get this 9 on top, and let's just check. 5. That's 18, all right. This is 18 as well. Now 20. So the remaining possibilities are 4, 7, and 8, and only 4 will work. And it works. It does work. Now let's have a look at what can be obtained just by Sudoku. On this column we need 3, 4, and 6. On this row we need 3, 4, and 9. 4, 4, 4 is here, 3 and 9 there. Oh, and this 4 has an impact on this 23. So it won't use 4 digits, it will be 5 or 6. Oh, but I see where it's going. The missing digits, I mean the ones that are not in the sum, have a sum of 22. And if I make this a 6, then these 3 digits must have a sum of 22. And I know by Kakuro, by Kira Sudoku, that 22 in 3 digits must be 985 or 967. So it has to use a 9, and this 9 is not in those three cells. So this has to be a 5. This is a 6, this is a 5. And now those 5 digits must add up to 23. And actually this 7 gives us the answer. It has to be a 7, and it works. Right? Yes, that really works. So we have used all of the clues, and the remaining of the solve must be plain Sudoku. So this is 8. We get 2 and 3 here. On this row, 2, 3, 4, 3 and 4, 2 and 4 here. They must be there. So this is a 6, this is a 3, that's a 9, that's a 3. Here we need now 3 and 5, and because of this 3, that's 5 here, 3 there, 2 is here. We need 4, 5, and 7. 4, 5, 7, okay. 7, 5, 4. Here 6 and 5, there's a 5 here. 8 and 9, there's an 8 here. Okay, I think I don't need to explain the remaining steps. They are pretty well. That's it. That solves this X-sum Sudoku puzzle. And I would say that 10 points was perhaps a little underrated. It was not that difficult, and I may have chosen an unnecessarily difficult path. I mean, this logic about 22 may have been a little bit too complicated. Perhaps I should have focused more on those 18 clues and moved on in different manner. Well, anyway, it works, and that's all that matters. Thanks for watching this video, and see you soon on Sudoku Mahabharat.